Good day, everyone. Welcome to I Squared Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at applications of the cosine rule in solving problems involving bearings and distances. Yes. So today, let's look at this. Example 1. Two ships A and B left port C at the same time. Full stop. Now ship A sails 10 kilometers, 10 kilometers at a bearing of 0.68 degrees. Why should B sails 16 kilometers at a bearing of 137 degrees, calculates the distance. Calculate the distance between the two ships and the bearing of ship A from ship B. Yes, and the bearing of ship A from ship B. Now let's look at this question again. Now two ships A and B left port C at the same time. Ship A sails 10 kilometers at the bearing of 0.68 degrees, while ship B sails 16 kilometers at a bearing of 137 degrees. Now calculates the distance between the two ships and the bearing of ship A from ship B. Now solution. Now remember, we are looking at the application of the cosine rule to solving problems involving bearings and distances. Now, when solving problems involving bearing, the first step is to draw the four cardinal points. Yes, to draw the four cardinal points. Now, let's take note of this word, left. Yes, left. Now, they said the two ships A and B left port C at the same time. Now, this is port C. Yes, this is port C. They left those ports at the same time. Now, ship A sails 10 kilometers at a bearing of 0.68 degrees. Now, 68 degrees, we take it from here. Remember, the whole of this, from here to this point, is 90 degrees. So here, 68 degrees should be somewhere here. So here, you take it straight. Now, this is 68 degrees. Now, this is ship A. Yes, this is ship A. This is ship A. Yes. I remember ship B also left those same ports. Yes. And sails 16 kilometers at a bearing of 137 degrees. Let's change this out to on the bearing. Yes, because we're dealing with direction this at the same time on a bearing. Okay, now in this case, if ship B actually sails 16 kilometers on the bearing of 137 degrees, it means you start from here. Yes, those points, the north pole of the ports. Now, this is 90 degrees, and here we have 137 degrees. So it means You add 47 degrees to make it 137. So we have 47 degrees inside. So now, looking at the distance, now ship B sails 16 kilometers, while ship A sails 10 kilometers. So it means this will be, yes, these are ship B. Yes, these are ship B. Yes. So here, this is the North Pole of ship B. Yes. Now let's look at this angle now. Ship A sails 68 degrees. So it means from this point to this point here, we said it's 68. So it means what we have left here. Now let me use my red ink. Here we have 22 degrees left to make it 90 degrees. 22 degrees left. Yes, to make it 90 degrees. Now I remember ship B sails 137 degrees. So we actually added 47 to 90 because we said from this point to this point is 90 degrees. So here now we added 47 degrees. So it means the whole of this now will be 69 degrees. Yes, 69 degrees. I remember ship A sails 10 kilometers. So let's do it out. Here we have 10 kilometers. And ship B sails 16 kilometers. So here we have 16 kilometers. 16 kilometers. Now the question is, what is the distance between the two ships? That is, between ship A and ship B. Yes, we have to find the distance between ship A and ship B. So the distance is from here to this point. Yes, that's the distance between ship A and ship B. Now let's look at this now. Now this is the case. Let's look at this triangle very well. Now this is the case of having two sides and an angle cutting across the two known sides. Yes, so this is what we have now. This is the triangle. Yes, this is a triangle like this. Yes, this is a triangle. So we have this side. We have this side to be 10 kilometers. So this side here is 10 kilometers. This side is 16 kilometers. And the angle in between is 69 degrees. Yes, so this is our A, this is our B, and here we have C. Sorry, this is C. Yes, this is the ports. So here we have C, and this point is our B. Yes, that should be. So in this case, we are going to use the cosine rule. Remember we said the cosine rule can be applied when a triangle with two known sides and an angle cutting across the two known sides is given. Yes. So I remember we said the side facing our big A, there is big A, but this side is small a. The side facing the big C is small c. The side facing the big B is small b. It means to get the value of C, our C square is A square plus B square minus 2AB. Then here we have cos big C. Yes. So it means here we have C square will be equal to, the value of our A is 16 kilometers. So here we have 16 square plus the value of our B is 10 kilometers. So we have 10 square minus 2 times 16 times 10. Then we have cos big C. And big C is 69 degrees. Yes, it's 69 degrees. It means here our C square will be equal to, now let's get the value of 16 square. Yes, 16 square plus 10 square. So 16 square is 256. So we have 256 plus 100 minus 2 times 10 is 20. 2 times 16 is 32. 32 times 10 is 320. Then cos 69. Now the value of cos 69 is 0.3584 approximately. Yes, so it means the value of our C square will be equal to, this is 356 minus, now let's see that value times 320. Yes, times 320. That will give us 114.68. 114.68. Yes, 0.68. So it means C square will be equal to minus 356. Yes, so that will give us 241 plus 32. Yes, let's take it again. 356 minus 114.68. So that will give us 241.32. 241.32. So the value of our C will be the square root of 241.32. So C will be equal to the square root of that value. That will give us 15.53. Yes, that's 15.53. The unit is in kilometers, so this will be kilometers. So it means the value of our small c, which is this side, is 15.53 kilometers. Yes, kilometers. Now, in this question, they ask us to get the distance between the two shapes. Of course, we have seen the distance between the two shapes as 15.53 kilometers. So that's the distance between shape A and shape B. Now they went further to ask us to find the bearing, yes, to find and the bearing of shape A from shape B. The bearing of shape A from shape B. Now this is shape B, yes, and this is shape A. So now the bearing of this shape A from B, then you start from the North Pole here. So this is 90 degrees, 90 degrees, 90 degrees. Then we are adding this angle from here to this point. Yes, we're adding that value. So now if you look at this very well, you'll see that this angle from here to this point is 47 degrees. So if this angle is 47 degrees, it means this angle too will be 47 degrees. Yes, that angle will be 47 degrees. So 47 degrees, let's put it here, 047 degrees. Yes, 047 degrees. So now it means the bearing of shape A, from shape B, we are hitting it here, please. Yes, this is where we are hitting it. This is the bearing of C. This is the bearing of C from B. The bearing of A from B, you have to touch A. So this will touch A. So it means we need this angle. Yes, we need this angle. So now let's call this angle angle B. Yes, let's call that angle angle B. So to get the value of angle B, now remember the sine rule. So here we have, these are small b. We have b all over sine big B will be equal to, remember, we have known the value of our small c. Yes, our small c is 15.53 kilometers. So now the big C is 69 degrees. So it means we have C all over sine big C. So the value of our B is 10 kilometers. So we have 10 all over sine big B will be equal to C. The value of our C is 15.53 all over sine 69 degrees. Yes, our big C is 69 degrees. So the next step is to cross multiply. Yes, it's to cross multiply. Now when you cross multiply, we have 15.53 sine big B will be equal to 10 sine 69 degrees. Yes, 10 sine 69 degrees. So it means here, to get the value of sine big B, we have to divide through by the coefficient of sine big B. And the coefficient is 15.53. 15.53. It means here we have 15.53 sine big B divided by 15.53 is equal to 10 sine 69 degrees all over 15.53. Now this 15.53 will go with this 15.53. So it means we'll be left with sine big B. Yes, sine big B will be equal to, now let's see this now. Let's see sine 69. Yes, sine 69. Yes, that's 0.9336. Yes, so we have 10 in bracket 0.93. Then here we have 36 approximately. Yes, because what we have there is 0.93358. So approximately 6. So divide by, we have 15.53. So sine big B will be equal to, you multiply that value by 10. Yes, when you multiply by 10, we have 9.336 divided by 15.53. So sine big B will be equal to, yes, now that value divided by 15.53. So if you divide it by 15.53, we have 0.60, yes, 6011. So that's the value of sine B. Now remember, we are not looking for sine B, we are looking for B. So to get the value of B, our B now will be equal to sine inverse. Yes, the sine inverse is 0.6011. So it means our B now will be equal to shift sine. That will give us 36.95. So here we have 36.95 degrees. So that's our B. So it means the whole of this angle here, from this point to this point, is 36.95 degrees. Okay? So now it means the bearing. Now let's look at the bearing. The bearing of ship A from B. Yes, that's the question. The bearing of the, so we should find the bearing, the distance between the two ships, and the bearing of ship A from ship B. So from ship B, you will start from here, from the North Pole. So here you have 90. Yes. So it will be, we have 90 degrees plus, now this is another 90 from here to this point. So plus 90 degrees, plus 90 degrees, plus, we have another 90 from here to here. Yes, from this point to this point. So we have 90 degrees. Then plus, here we have 47 degrees. Here we have 47 degrees. And we have B, angle B. Because this is our A. This is A. So we are stopping here. So we have 36.95. 36.95 degrees. So adding the whole of this, it is 270. Yes, so 270 plus 47, yes, plus 36.95. Yes, so that will give us 353.95 degrees. So this is the bearing of ship A, that is the ship A from ship B. So thank you so much for listening. Remember to share with your friends, like and subscribe. And in case you have any problem that has to do with bearing and distance, you can contact me. So thank you so much for listening.